Hi again everyone. In this video we're going to talk about how to solve inequalities through a simple example, and before we get to that, let's talk a little bit about the motivation. Why would you want to know how to solve inequalities, and how are they important? How are they useful? Well, inequalities arise in almost all areas of mathematics and its applications, and a good understanding and ability to handle inequalities gives the user the power to solve much more difficult problems where inequalities arise. So, for example, this might be in optimization, in linear programming, in numerical approximation of solutions to equations with error bounds, or in areas of engineering. But let's just do a simple example first off and build our intuition a little bit. So here's the problem. We asked to solve this inequality for x. Now, the first thing we note is that we exclude the point x equals -1 because we're dividing by 0. Now, I'm going to label this equation, or this inequality really, as star. Now, what we're going to do is a two-step process here. We're going to simplify star as much as possible through algebra and manipulate it, and then we're going to solve that simpler inequality. Okay, so we want to simplify our original problem as much as possible because it makes it easier. So to do that, we would like to get rid of that x plus 1. So the temptation here is to multiply both sides by x plus 1, but that's fraught with danger because x plus 1 is sometimes positive and sometimes negative, and then you will have to worry about the inequality sign. So what we're going to do is multiply both sides by a positive expression. That way we can keep the existing inequality sign. So we're going to multiply both sides of star by the positive expression x plus 1 all squared. Now notice x is not equal to -1, so this is always positive. So if we make that choice, we're going to cancel out the x plus 1 on the bottom. So things are going to simplify, hopefully. And I can keep the same inequality sign because I'm multiplying both sides by a positive value, or positive expression. Okay, so we can cancel and rearrange. So let's get all the x's on one side. So we can form, bring that over to the other side, the following. Okay, right, so now we can still simplify this left-hand side. We've got a common factor of x plus 1, so let's take that out. Okay, so I'm going to take out a common factor of x plus 1, and I'm left with this. Alright, so if I expand this bracket now and simplify, I'm going to get a half x plus 3 on 2 here, and I can take a common factor of half out of that. Okay. So we've now reached the stage where the original difficult inequality is simplified. How's it made simpler? Well, you'll notice the left-hand side is just a quadratic. Okay, so it's going to be some sort of parabola. Okay, so what we can do now is label this double star and solve this. Now you can solve this algebraically by seeing where the expressions in each bracket is positive and negative, but that's quite complicated. So what I like to do is draw a graph of the left-hand side and just visually see where it lies above the x-axis. So let's do that. So we've simplified accordingly, and what we're going to do now is the second step of the process, and that's solve the simpler inequality. Any solution to the simpler inequality will also solve our original inequality. Okay, so to do this, I'm going to let g of x be the left-hand side of double star. And let's sketch the graph of g. Okay, we're going to have an x squared, and the coefficient of that x squared is going to be positive. So we've got a U-shaped parabola that cuts the x-axis at -1 and -3. So let's look at this and see, okay, where does the graph lie above the x-axis? Well, the corresponding x point, you can see it's here and here. The corresponding x points that lie on the x-axis are here and here. Okay, so the graph lies above the x-axis when x is greater than -1, or when x is strictly less than -3. So we can now solve our problem. We've solved the simpler problem, and we can go back, and these will be solutions to our original starred inequality. Okay, so let's make a conclusion. Okay, so x is strictly greater than -1, or x is strictly less than -3, or equivalently, in interval notation, we could write the solution like this. Okay, so just to recap, we manipulated the original difficult inequality to form a simpler inequality. Then we solved that simpler inequality, in this case, graphically. All right, so let's look at the bigger picture though. What are some of these techniques that will work on general problems? Okay, well, basically I'm just going to talk about the method. The idea is to simplify the original inequality as much as possible through algebra. Okay, you want to manipulate it algebraically to form something simpler. In this example, I multiplied both sides by a positive expression and then rearranged. It's important, if you want to keep the original inequality sign, you need to multiply through by something that is positive. And the second step was to solve the simpler equivalent inequality either graphically or algebraically. I did it graphically. Okay, so I'm going to leave you with an important exercise or an example. It's important to recognize that you get good at maths by doing maths, not just watching. So see if you can solve the following inequality for x.